Take a look at adding and subtracting radicals. Let's look at our first problem. We got the 9 cube root of x minus 4 cube root of x. Instructions say add or subtract is indicated. Assume all variables greater than or equal to 0. Now, it shouldn't, in mathematics we cover combining together like terms, like radicals, so forth, same radicals. It should be just combining together like items. No matter what you're dealing with, if excluding the number out in front, the coefficient, if whatever you're dealing with, if they're exactly the same, then you can add or subtract the numbers that are out in front. It does not matter if they're radicals, if they're x's, if they're i's, it just works that way. Well, since these are both the cube root of x, they both have the same index and radicals exactly the same, then 9 minus 4 will give us 5 cube root of x. And that's our answer. Again, you just add or subtract numbers that are out in front. Let's take a look at this problem. We got 3 square root of 5 plus 2 fourth root of 5 plus 6 square root of 5 minus 8 fourth root of 5. Well, all of these are a radical, and they all have 5s under them, but some of these are different. This is a square root, and this is a square root, where this is a fourth root, and this is a fourth root. I'm going to rearrange it so the ones that are the same are together. So 3 square root of 5 plus 6 square root of 5 plus 2 fourth root of 5 minus 8 fourth root of 5. Well, again, these radicals are the same, so I can add the numbers in front. 3 plus 6 is 9 square root of 5. And these ones are both the fourth root of 5, so I can add or subtract the numbers that are in front. 2 minus 8 gives me a negative 6 fourth root of 5. And that's our answer. Now here we got the cube root of 16 minus 6 cube root of 2. Well, the radicals are different. We can't combine them together, but 16 looks like something I can simplify. If I do the factor tree on it, start with my first prime, which is 2. It is divisible by 2. 2 times 8 gives you 16. So 2's prime, so I circle it. Then I go to 8. It's divisible by 2 also. 2 times 4. 2's prime, so we circle it. And 4 is 2 times 2. And those are prime, so I circle them. So this becomes 16 is 4 2's. Minus 6 cube root of 2. Now our index is 3. If your index is 3, you're looking for a set of 3 of something. Well, here's 3 2's. So those 3 2's going to come out in front as a single 2. So I got 2 cube root of 2 minus 6 cube root of 2. Now that I've simplified the radicals, you notice these radicals are the same, so I can add or subtract the numbers that are out in front. In this case, 2 minus 6 gives us negative 4 cube root of 2. And that's our answer. Let's take a look at this one. We got 7 square root of 45 x to the 5th plus 3x squared square root of 20x. Well, we can definitely do some simplifying here. Let's look at the 45. If I do the factor tree, 45 is not divisible by 2. I'll go to 3, my next prime. It is divisible by 3. 3 times 15. 3's prime, so I circle it. Now 15, it's divisible by 3. 3 times 5. 3 and 5 are prime, so I circle them. Let me go ahead and do 20 while I'm over here. 20 is 2 times 10. Start with the first prime. 2's prime, so we circle it. 10 is 2 times 5. 2's prime and 5's prime, so circle both of those. Now, the x to the fifth. Let's go ahead and look at it while we're here. We're going to take our 5, divide by our index, and that gives us 2 with the remainder of 1. Now I'm working with this x to the fifth right here. So we take our power, which is 5. That's where this 5 comes from. Divide by our index. Index is, since this is square root, it's by default 2. And this is old style division. 5 divided by 2 is 2 with the remainder of 1. Now this tells me how many x's I have come out, and this is how many stay in. So I'm going to have 2 x's come out, so I got x squared out in front there. Now 45 we said was 3 times 3 times 5. And then x's we have 1 stay inside. So we have x the first stay inside. Plus 3x squared, 20 we said was 2 times 2 times 5. Well, let's simplify the radicals a little bit more. Number-wise, we're looking for a pair of somethings. Here's a pair of 3's. A pair of 3's is going to come out in front as a single 3. And here's a pair of 2's. A pair of 2's is going to come out in front as a single 2. So we got 7 times 3x squared, and then we're left with 5x inside, plus 3 times 2, a pair of 2's comes out as a single 2, x squared with a 5x inside. 7 times 3 is 21, so we got 21x squared, square root of 5x, plus 3 times 2 is 6, x squared, square root of 5x. Now that we've simplified the radicals, notice that this it's not a radical, but notice this is the same as this. Like items. If you got everything's the same except for the number out in front, then you can add or subtract the numbers out in front. 21 plus 6 is 27. X squared, square root of 5x. And that's our answer. And let me start a new page. And we'll look at the next problem. Okay. 4 cube root of negative 7x to the third plus 6x cube root of 189 plus cube root of 56. Okay. Well, let's simplify the radical. And you got a negative out in front, or negative inside, then you take negative and put it out in front. So we'll start with that. Now let's also look at the x's here. So take our power, which is 3, divide by our index, which is 3. So power, divide by the index. And this is old style division. 3 divided by 3 is 1 with the remainder of 0. So this tells us how many x's we're having come out, and this is how many stay in. So we have the negative out in front, 4 and the x, and then we got the cube root of 7. Plus 6x cube root of 189, plus the cube root of 56. Well, let's look at the factor trees for these, because I'm not seeing them. But I was going to show you the factor tree anyway. It's not divisible by 2. It is divisible by 3. 3 times 63. 3 is prime, so we circle it. 63 is divisible by 3. 3 times 21. 3 is prime, so we circle it. 27 is, or 21 is 3 times 7. So those are both primes, so we circle them. 56 is divisible by 2. 2 times 28. 2 is prime, so we circle it. 28 is divisible by 2. 2 times 14. 2 is prime, so we circle it. And 14 is 2 times 7. And both of those are prime, so we circle. Okay, so we got negative 4x cube root of 7 plus 6x cube root of 3 3's and 1 7. So 3 3's, 1 7. Plus cube root 56, we got 3 2's and 1 7. Well, our index is 3, which means we're looking for the index is numbered in a slot right here. So we're looking for a set of 3 of something. Here's 3 3s. They're going to come out in front as a single 3. And here's 3 2s. They're going to come out in front as a single 2. So we got negative 4x cube root of 7 plus 6 times, and these set of 3 3s are going to come out as a single 3, so that's 3x cube root of 7 plus, and the 3 2s are going to come out as a single 2, and then cube root of 7. So that gives us negative 4x cube root of 7 plus 6 times 3 is 18x cube root of 7 plus 2 cube root of 7. Now some books handle this differently, so I'm going to show you both ways of simplifying, and then you have to do the appropriate according to whatever you're studying. Now notice that this right here is the same as this. That means I can combine those together. Well, negative 4 plus 18 gives us 14x cube root of 7. And then this one carries along. I can't combine these together because this one's got an x cube root of 7, but this one doesn't have an x. So that'd be our answer. Other books will take this approach. Since they all have a cube root of 7, they'll factor the cube root of 7 out. And that leaves you negative 4x plus 18x plus 2. When I take away the cube root of 7, I'm just left with what's in front, which then simplifies. Negative 4x plus 18x is 14x plus 2. Now I see that after I've done that, they have a GCF in common, greatest common factor. I can factor a 2 out, and that gives us 14 divided by 2 is 7, so 7x plus 2 divided by 2 is 1. And a lot of books will write this in this form. They'll put the cube root of 7 at the end, like that. You can do that because multiplication is commutative. You can flip them around. Let's take a look at this last problem. I think I got room here. Got square root 4x minus 4 minus square root of 16x minus 16. Well, to begin with, I notice that these have a 4 in common, so GCF-wise I can factor out a 4, and that gives me x minus 1. And these over here I notice have a 16 in common, so I can factor that out, and that gives me x minus 1. Well, if I do the factor tree, prime factorization of 4 is 2 times 2. Those are both prime, so then 16 is I start with my first prime, which is 2. 2 times 8. 2's prime, so I circle it. 8, still divisible by 2. 2 times 4. 2's prime, so I circle it. And 4 is 2 times 2. And those are both prime, so I circle it. Now, some people will teach putting this 4 times 4, and you can do that. I like this method because then the only thing you ever have to worry about is the one on the right side. The other one will always be a prime. Okay, so we said 4 is 2 times 2, x minus 1. Minus 16 is 2 times 2 times 2, well, 4 2's, times x minus 1. These are square roots. There's no number in the slot right here, so we're looking for pairs of something. Here's a pair of 2's. They're going to come out in front as a single 2. Here's a pair of 2's. They're going to come out in front as a single 2. And here's another pair of 2's. They'll also come out in front as a single 2. So we're going to have 2 square root of x minus 1 minus, and when these come out in front, they come out with multiplication between them. So that pair of 2's gives us a single 2. This pair of 2's gives us a single 2. Square root of x minus 1. So we got 2 square root of x minus 1 minus 2 times 2 is 4, square root of x minus 1. Now remember what I said. Like items. Whatever it is, if they're exactly the same, which these are, then you can add or subtract the numbers that are out in front. Well, 2 minus 4 gives us negative 2, square root of x minus 1. And that's our answer. And I believe that was the last, yeah, it was the last problem.